welcome to our chemistry practical. You're missing out, so we decided to film some of it, and here it is.
So we're looking at experiment 26, transition metals and forming precipitates.
The worksheet to help you get along.
So over here we have Mr. Armitage with some manganate 2+ solution.
And we're adding some sodium hydroxide in excess. Be such a good eye movie.
Look at that girl.
That's crazy.
Precipitates.
We've got some manganate sulfate solution, but this time we're adding ammonia to it.
The next experiment is chromium 3+ with sodium hydroxide.
Who's the director?
You're doing a great job.
Oh.
That colour change.
So looking at these solutions in turn, the one to the far left is the manganese 2+ ions. We've added sodium hydroxide to this and it formed a pink solution before then turning into a cream precipitate. The second example, this one here, is manganese 2+ again, but this time we've added ammonia to it. This, like the previous example, formed a pink solution before turning into a cream precipitate.
Next, we have a solution of chromium 3+, which on adding sodium hydroxide to it, it forms a violet solution, which then develops into a green precipitate, and now, as you can see in excess, it's formed a green solution. The final test tube that we have is the chromium 3+. We've added ammonia to this. The solution has gone violet. It's developed into a grey-green precipitate before now turning into a purple solution.
Yeah.
So hey guys, welcome to Chemistry 101 without Bo, Jazz and Johnny. We are doing the student experiment part of experiment, what number is it? 26, transition metal hydroxides. So please follow along, be reading your yellow thing, and let's get to it.
Okay, so we've got some copper sulfate solution, and we're going to be adding that to a test tube.
Note the colour of the solution. What colour is that? Oh, it's blue.
Look, matching.
Beautiful.
Same as the gloves you hold. We're going to do it to another one because.
Sarah, you're not present in the vlog.
Okay, we now have 2 test tubes of copper sulfate, and we're going to put those in a boiling tube rack. So yeah. Q, get a boiling tube rack.
Beautiful. Until it's in excess and there are what? No further changes.
But it's out of camera, it's out of camera.
Oh shoot, that
but it's not, it's just like we want it set to stage now.
Yeah, of course. Oh, look at that, there's a precipitate. I hope you can see that there.
God.
Precipitate.
You've got to keep adding. You're meant to add loads.
I think drop wise, guys.
We're going to get a bit of.
Okay, you know what, I'm just going to. It's not really focused, but.
So we don't stay here all day.
Wow, Syriac, you're killing the vibe. I'm actually a chemicist.
Chemicist?
Yeah.
Look at that precipitate, beautiful.
That's a
colour.
whole different thing to this. There you go.
Thing.
Look at that, that is beautiful. We keep adding some more, see how far it goes. Oh, there we go, it's even darker shade. Look at the comparison there. Beautiful. Keep adding.
Oh my god.
That's a whole sea. It's got some fishies in there. precipitate is forming.
Yeah.
I'm called a YouTuber, Syriac. Have you ever met a non-cringe YouTuber? This is beautiful. Look at that blue, it's almost the same shade as this now. It's got a lot of precipitate in that. We're going to record our observations and then we'll get right back to it. Beautiful. Oh, you have to shrink. Wow, I'm actually.
So now we are adding, let me just get a nice shot there, the ammonia solution to our copper sulfate. So we're just going to add till it's an excess. Whoa,
Look at that.
that is
go.
crazy. Can you see those
Can
colours?
you see that? We need like a little white background.
Oh my god.
Wow. That is beautiful. It's the colour of Lily's eyes.
Stop it, you.
I'm just messing with your camera.
No biggie. Keep going.
It's
So
actually really nice.
this is a really cool colour, this. Look at that shake. It's really pretty. I'm beginning to look like an Ashes coat. The complex is dissolving.
Oh, I just covered your mouth.
Yeah, you did, but you know,
Sorry.
it's all for the effect.
Yeah. I didn't know what you said now. I have to hear it.
Turn the volume on. Can you take that? It's currently being shaken.
Chicken.
Shaken. What type?
Chicken.
And look at that beautiful
Look at
colour.
that. Look at that.
Look at the difference in those two. It's a nice kind of
Dark
purpley
blue, dark blue
dark blue,
solution.
Dark blue. Write that down.
dark blue. Yeah.
Beautiful.
Cool. Bye. So now,
Welcome back
yeah, it's been a while.
to Chemistry Vlogs.
We are now
Goodness.
going to do this with some iron chloride, which is Fe2 plus iron, because it's iron 2. Yep. So we're going to add that to 2 test tubes.
Oh, look at our handy.
And
what's
then
it
we're
called?
going to add some ammonia again, and we're going to add some sodium hydroxide to another
What do
one.
people call when they come in? They do other things.
So this is our iron 2 sulfate. I hope you guys can see that. We're now going to be adding that, a little bit to each. We're just going to go and pour it on in. So notice it's kind of like a gross colour. Yeah, it
We
looks a
need
bit
to be
like
more
pea.
specific with the colours. A green
It looks
colour.
like pea.
It does look like pea.
A green colour.
A green
Pale
colour.
green colour.
Pale green. Add that in. Go.
Me too.
2 test tubes. Right, that is in.
And now we're going to add hydroxide in excess
So
once
I'm
again,
going to hold this up.
so you can all see. Oh, look at that!
Ooh.
Nothing happened.
Okay. Gold.
So what we're looking for here is we're looking for the formation of a green gelatinous precipitate.
Gelatinous.
Oh!
It's
Oh.
called, we use the word gelatinous because it is jelly-like. I always think it looks a bit like frog spawn. Dark green.
Yeah, I'd say that's a defo dark green. Should we
That's
get a white
so
background behind that?
Yeah. I'm going to hit that there. Look
Oh,
at that
hey,
beauty.
crazy. Don't get it on me.
Yeah, I couldn't
That's
see
what I'm
the
saying.
That's what he said.
So
Beautiful.
as we continue to add the sodium hydroxide, you'll notice that it doesn't redissolve. It's an insoluble precipitate.
And that's that.
Largely just. So it's our finished result right here. Got a nice kind of ombre effect going on. But
What's
that's
really
'cause we
interesting is we can
shaped it.
see down here at the bottom, we can see sort of a brownish colour, and that's indicative of some of the Fe2 plus ions turning into Fe3 plus ions. But the main precipitate here at the top is the green Fe2 plus ions which are present in the hydroxide.
So now we are adding the ammonia solution to our copper
Not
2
concentrated.
sulfate. So we're just going to keep going until we get a little
Just a little
cool
background
thing
of
going
that
on.
thing
Oh,
as
it's
well.
quite similar.
Oh.
Nash is going to hold it up for
angles.
us. Wow.
Look at that.
Wow. Oh
That's what we
we're
call
lacking.
chemistry. Not really getting much in there, are you?
Yeah, well, it's a dodgy.
Didn't feel it.
It's dodgy. The bottle's lacking.
So once again, we can see the formation of a sort of dark green gelatinous precipitate as the Fe2+ ions forms a complex and precipitate with the ammonium ions.
That takes a job well done.
Yeah. Finished product. Right there.
Beautiful.
So now we are adding iron 3 chloride to each test tube, a little bit in each. Just going to go on and
Pour that in.
add a little bit of that in. It's a nice amount there.
That lovely orange colour. So we're going to see
Yeah.
if there's any colour change. Orange to
No
something else.
precipitate in there.
It's
Right,
beautiful.
and that's it. Off the chart.
Off I go with the sodium hydroxide. We now know the drill. In excess, of course, and we just go for it.
Wow.
See that darker orange there? That's absolutely beautiful. The precipitate being formed here.
What's the consistency of the precipitate, Nash?
It's gelatinous.
Gelatinous,
It's a
that is
long
right.
English word.
Absolutely.
Please write that down. I will be after I complete the experiment. It's looking beautiful. So we have this orange to dark orange with this gelatinous precipitate in there.
Wow.
That is what we
That
like
is
to call
beautiful.
science right there. This is the wrong colour. Science.
Right. So now we've got our iron
You're just the
3
icon,
chloride
really.
again. And Nash is going to hold it.
I will
Here
hold
we go.
I will
Sorry,
hold it.
Syriac.
You don't have to hold it if you really don't want
Well,
to.
yeah, but if you just assume I want to hold
Like,
it.
I can put it in that
Yeah, it's fine,
direction.
don't worry.
Do that.
Okay. We're going to add some of our
How does that
ammonia
translate?
solution in excess.
Oh,
Oh
there we
my
go.
god. Look at that gelatinous precipitate going in there. It's kind of an orangey, browny, rusty
That's what we
colour,
like to see from Fe3+.
which is kind of what we're expecting.
When we compare that to the FET that we had, hopefully you can see now the sort of the orange-brown at the bottom, which is indicative of some of the Fe2+ ions turning into Fe3, but the green gelatinous bit at the top is definitely Fe2+.
Gelatinous.
That's it, we're good, that is good.
Just one more for luck.
Happy days.
Beautiful. We love to see it. We really do.
Science.
So sorry.
So we can see.
I was going to try and get his face in.
So just looking here, as we can see, we've got the copper sulfate solution, which we've added sodium hydroxide to. As we do this, you should see the blue solution form a pale sort of blue turquoise precipitate. We can see that in here. Adding the ammonia solution, what we can see is we saw the formation of a blue precipitate, which has since now dissolved and turned into a dark blue solution. Looking at the Fe2+ in the presence of sodium hydroxide, what we can see here is a dark green gelatinous precipitate. This brown here is slightly misleading, as we've said already. These are Fe3+ ions at the bottom of the solution. Here we've got the Fe2+ ions, which are mixed with the ammonia to form a complex there. And here, looking at the Fe3+, we can see these characteristic brown gelatinous precipitates, firstly with the sodium hydroxide and then with the ammonia. Great work.
Thanks for watching.
Thanks for watching.